Well, the power line itself cannot be smart. It is a stupid power line. But the applications in the nodes, the connection points, those can be smart. And the protection equipment to protect the power line can be smarter. And by protection, I mean if there is a failure on a power line between two substations, you want to isolate that power line from the rest of the network. Otherwise, you will have what's called cascading effects. Cascading effects can take place, but the network in Sweden and many other countries are designed in such a way so you should be able to handle at least one fault. For that reason, you have what's called protection equipments. And you have systems for supervisory control. But of course, the customers can be smart, and I will come back to that. What you typically see, you will see more digitalized solutions in the network, but you must also remember that the power network that I was talking about was built in the 1950s, 1960s. At that time, the use of digital solutions was not as big. Really not, I would say. What we also have seen is that I mentioned the power line carrier communication on top of the power lines. So what we have seen is that the communication capacity, of course, has grown over the years. And the system that you have connected are more rather fully integrated today. And this is natural for you. You think of the cloud as what's the issue, really. But this is not so good colorful, but on this side it says operations scale MS and this on administrative IT. What I mean is that this side is the function used for operating the power network. You do not want anyone to tamper with this one. You know what tamper means? Fippla. And you don't want anyone with an office PC accidentally connected to the wrong thing. When we got our new SCADA EMS system in operation in Swedish National Grid in the beginning of 2000 something, 2001, 2, everyone said, finally it's there. But then we realized, well, how protected is this towards the rest of the world? Is it sheltered from the internet? Maybe, maybe not. It turned out that one of my colleagues was starting to test something. He talked to one of the guys at the communication department, said, can you give me some communication channels? I want to test something. Turned out that from his office PC, he could actually open or close the breaker in the network. Well, what is a breaker? You say, well, it's just what it says. It's strömbrytare, but breaker on the 400 kV levels, meaning that you actually break part of the network. With this one, should that be possible? No. So at that time, we started to talk more about security in the smart grid. And this is something I also would like to show you. In a substation, it turns out that you have quite a few access points. If you look into substation, you don't need to, you get these slides, no problem. Turns out that you have computers, you have substation equipment, but I was part of a working group where we looked into how many possible digital entrances do you have in a substation. Turned out that I think it was like 9 or 10 of them. 10 of them. Should that be possible? The answer is no. So this is again something you must deal with. And once again, the communication is important, but also the security. So what we ended up seeing with this new system was that the new SCADA system had sort of the same vulnerability as the normal IT systems. And you must deal with that. So typically you talk about critical infrastructure protection, like protecting the infrastructure, the roads, the water, but suddenly you have a term called critical information infrastructure protection, meaning that you must deal with that as well. When you talk about, I think this gives you some kind of flavor. When you talk about security, one way is actually talk about the CIA. The CIAs means confidentiality, integrity, and availability. The first one means, well, you should be able to read in a proper way. It should not be tampered with, and it should be right, and should be available for the right persons. Meaning that if I should have the access, I should have the access, no one else. If you and me should have the access, well, we should have the access, no one else. And it's not a way of saying, well, everything is forbidden. No. But when you introduce a new technical solution, what does an engineer want? En levnadsglad ingenjör. An engineer who likes to play. Well, she or he do not care about this one. Rather, wants the availability. You should be as open as possible in order to test new stuff. So therefore, what we typically have, maybe in the electricity business. No, you have it actually in many places. You have the AIC, so, meaning that you first introduce something and then you test, it was possible. And I believe it's probably the same thing in the biomedical arena, that first you try, is this possible to run? And then afterwards you realize, shit, I need actually to think about this thing with the security also. So if you take security courses, bear that in mind. You have a future, for sure. And I would say also there's an enormous need for awareness raising here. I was responsible for this almost 10 years ago within our company. I made sure that everyone took my course. Everyone. No one was outside my radar. And afterwards I thought, good, I'm done. Bullshit. I was not done, because you need to do this all the time. You need to tell people, this is important. You need to deal with this all the time. Smart meters. I was talking how to sort of include the customer into taking care of the network. Typically, you have a meter in your home. Maybe you're living in a student dorm, you don't have a meter. But anyway, with your parents or an apartment, you have a meter. And typically, the purpose is to sort of to collect the data. How much do you actually use? How much electricity you use? And that is taking place now. But it's of course not so long to the thought, can you actually control the meter? Can you do that? Can you maybe open something? Close something? Can you switch off the power for a house? And we start doing that. And the reason why I ask this is because now we are now talking about a situation where you may have electric cars connected to the network. Can you open or close that one? Can you maybe get part of a household to balance the load in a power network? But when you do this, and something goes wrong, and I come home to a house after 2 weeks of vacation in a mess because something has gone wrong, who is responsible for that? When by mistake or by intention, digital tampering, a household is disconnected for 2 weeks, and the owner of the house gets damages by destroyed food or water leakage when he's away. Who is responsible? I have not heard Vattenfall saying, we are responsible yet. And I addressed this question many years ago. And my time is running. Yeah. Okay. So basically, due to climate goals, we introduce renewables. That will change the requirements on power transmission. We have a fully integrated power network. We have communication systems with enormous communication capabilities due to our fiber networks. But we must also deal with the cybersecurity issues, which is sort of an essential part of a smart grid infrastructure. The trainee program, for those of you who are interested, it's now actually up and running. You can look at our website. We accept trainees every other year. And we have internship with other TSOs also. Okay, I leave it at that. As that. Okay, thank you.
Thank you so much, Laura.
Thank you.
Do you have fast questions, maybe? Okay. Thank
End
you.
of the day. Okay.
So this brings this special edition lecture to an end. I hope you enjoyed. I take the chance to thank also again Yoran, Bengt, and Knut for being with us today. And please don't forget to subscribe for the topic presentation by tomorrow. And yeah, the lectures. I will upload them on Ping Pong once I get them, and also the videos. Thank you all.
Okay, thank you. I will send it to you.
Yeah,
Good.
thank you so
Okay.